Okay, for these last three homework problems for Chapter 3 for FEP hydraulics, I'm going to put them all together because they're very similar and they share the same runoff coefficient. So we're going to use the following data for 8, 9, and 10, and we're told acres and the runoff coefficient for that type of ground. So first is single family residence, then apartment, then neighborhood business, then light industry. So we'll find that composite coefficient first, and then we'll solve 8, 9, and 10. They're all pipe culverts under an interstate, so we can figure out what year we're looking for design. And then we're looking at different cities and different times of concentration to find the design discharge. So first thing, let's go ahead and start it from the top and find that runoff coefficient for that whole group. So we can set up our table here for that. We've got a bunch of different areas here. So we've got 2.4 acres is our first, and it's got a coefficient, focus that in a bit, of 0.4. And so then we'll take that area and multiply it by the coefficient, and we get 0.96 for that first one. And then we have 2.3 acres, and that's got a coefficient of 0.5. So multiplying that across gives us 1.15. And then 1.3 acres of neighborhood business, which has a runoff coefficient of 0.6. So multiplying those across, 0.78. And then last 3 acres of light industry, which has a runoff coefficient of 0.7, which gives me an area times that coefficient of 2.1. So now we're just going to go ahead through that process and do a weighted average. So first we'll add up all the areas, and so when I do that I get a total area of 9 acres. And then I'm going to add up all these areas times their individual coefficients, and that gives me a total of 4.99, and that would also be acres since I multiplied acres by coefficients. But to find that composite coefficient, I'm just going to take those acres over acres so they can cancel out. So it's the 4.99 divided by the 9, which gives me a composite coefficient of 0.55. So I can use that for all of the problems in this section here. And now, like I said, I'm dealing with a pipe culvert under an interstate for all 3 problems. So we'll start off just with number 8 here. But for a pipe culvert under an interstate, I can look up and see what design year I'm dealing with that. So pipe culvert under interstate. And so I'll go back to my table here that has all of that information. And I'll look at interstate, and then pipe culvert, and yeah, it is the 50-year storm, so that's going to be true for all of these problems. Problem 8, 9, and 10 are all based on that 50-year design because they're all pipe culverts under interstate. Okay, but now I'm going to have some differences. So let's start with Raleigh. So this is going to be number 8. We know that the time of concentration is 20 minutes. And we're going to look at that Raleigh chart. So let's go ahead and figure that out for the 50-year design. So here's Raleigh. Here's a time of concentration of 20 minutes. And I'm going to follow that up until I see that 50-year bent line here, and it's the second one from the top because 100 is the top, so second one down, and it looks like that's coming right at the 6, maybe a little bit before the 6, so I'm going to call that intensity 5.9, but you can call that closer to 6 if you want. So I'm going to say that I is equal to 5.9 inches per hour. So let's just go ahead and solve for that Q for number 8. So Q is going to be that composite coefficient times that intensity times the area. So 0.55 times 5.9 inches per hour times the 9 acres. And so that gets me a total of 29 cubic feet per second. So that's number 8. And then I'll go on to number 9 here. Number 9 is Asheville, and a time of concentration of 15 minutes. So I'll put that here. Number 9, time of concentration is 15 minutes. And now we're in Asheville. So let's find out what our I is, looking at our IDF charts. So our Asheville chart here. And again, we're at 15 minutes. And again, 50 year for all these guys. So 15 minutes will come up. Remember, 50 year is that second bent line here. So coming right about to here. So it's just about halfway between the 5 and the 6. I'm going to go ahead and call that 5.5. But again, you might have something a little different than me, but that's the general idea there. So 5.5 inches per hour. So again, we'll follow that cue. 0.55. Now this time 5.5 inches per hour, and then times the 9 acres. And so that gives me 27 cubic feet per second for Asheville with that time of concentration. And now my last one is, remember, Wilmington, and that time of concentration is 30 minutes. So, and same situation, pipe culvert under the interstate, same runoff coefficients. So time of concentration 30 minutes, and we're in Wilmington. So let's find that intensity again from the IDF chart for Wilmington. Page forward here. So now we're at 30 minutes, and again that second bent line down here for Wilmington, and that looks like it's just about to the 5, so I'm going to call that 4.9 for that intensity for 30 minutes there. 30 minutes up here, just almost to that 5 level. So 4.9 inches per hour. So for this one, my Q is going to be, again, 0.55 times 4.9 inches per hour times the 9 acres. And that's going to give me 24 cubic feet per second.